Assalamualaikum and hi. So this is our first chapter, which is relation and function. So this is the learning outcome. At the end of this chapter, you should be able to understand what is relations, their properties, equivalence, and order relation. And second one, you need to identify the domain and range of a relation. The third one, you will understand basic notions of function, special types of function, and their properties. And you will know how to find the value of a function and use function and the properties in solving problems. So these are the outlines for chapter 1. You will have 5 subtopics altogether. The first one will be relations and functions. The second one will be composite function. The third one is families of function. The fourth one is inverse function. And the last one will be the exponential and logarithmic function. So let's see the first one, relations and functions, hubungan dan fungsi. So what is relation? Hubungan. So relation is actually a mapping or pairing of input values with output values. So there must be a pair, a mapping or pairing, ada pasangan. Okay. So there are, in relation you will have domain and range. So domain is the set of input values. Anything that you the input or the starting values will be your domain, and the range will be the set of output values, hasil dia. So when you have domain, you map into the range. Okay, so you have these two for relations, input and output. So let's see. A relation between two variable x and y is a set of order pairs. Hubungan antara dua variable x dan y adalah a set of order pairs. Okay, an order pair consists of a x and y coordinate. So kita ada dua coordinate dalam relation. Dalam satu pasangan pair tu, kita ada x and y coordinate. A relation can be represented by order pairs, mapping, design, or arrow diagram, or table, equation, or written in sentences. So we will see this later on to see clearly what is a relation look like. So x values, first you need to know what is x values. X values are inputs, domain, and independent variable. Okay. So any of these is your x values. Like I mentioned previously, input is your x value and the output or the range is your y values. Okay. So y values are outputs, range, and dependent variable. Dependent variable is pemboleh ubah bersandar. This one is pemboleh ubah tidak bersandar. So anything in x and y, anything in x is your domain or your input, and for y values is your output and range. Let's see example 1. Consider the following example with the relations. Is the child of for two families. So this is the relation, is the child of blah blah blah. Anak kepada siapa? So let's say Alia is the child of Hamzah. Ali is the child of Ahmad. Asma is the child of Ahmad. So this one is your domain, set of all x, your x values. What you begin with is actually your domain. Okay, so this is your domain, and the one that you map to is your range. Kita punya y values ataupun range yang kita punya output. So the range will be Hamzah and Ahmad. So this is what we call as mapping diagram. Arrow diagram or mapping design. Arrow sebab dia guna anak panah, and also mapping design. This one is x, this one is your y. So second one, we can express relation using order pairs. So what does it mean by order pairs is like this. You written down in this form. Sorry. Okay, so you have Alia, bracket, Alia and Hamza. Alia is a child of Hamza. Ali is a child of Ahmad. Asma is a child of Ahmad. So this is written in order pairs dalam pasangan. So you have bracket and you have curly bracket, meaning you have all the sets over here. So you can either write it down using arrow diagram or mapping design or also in order pairs. So example 2, the relation 4, 1, negative 2, 3, 0, 2 can be represented by, so you have three options. You can represent these order pairs, this is order pairs, using a table. So if you're using table, you will have x and y. The x value is the x coordinate 4, negative 2 and 0, and y value is the 1, 3 and 2. This is using table. How about using mapping diagram? So it's look like this, right? Mapping or the arrow diagram, we call it as mapping or arrow diagram. So this is your x, your domain, this is your range. Okay, domain x, range is y. And how about using graph? Okay, so for graph, remember any input value is x-axis. Okay, x-axis. This is your x-axis. Your output value is y-axis. Okay, so you just map this point into the graph. So you will have 3 points over here. So you have 3 options: table, mapping, graph, and also the order pairs. So this is how you express your relation. Okay, there are these types of relations. There are 4 types of relation. Ada 4 jenis semuanya. The first one is 1 to 1. Satu kepada satu. So each element in set X is connected to an element in set Y. Maksudnya satu elemen di X ni akan pair dengan satu elemen di Y. 1 to 1, satu kepada satu sahaja ya. So this is the relation, is the square of 1 is the square of 1, 4 is the square of 2, and 9 is the square of 3. So all of the X values will pair to 1 each of these Y values. Dia cuma satu kepada satu sahaja. So this is what we call as 1 to 1. Next, you will have relation many to 1, banyak kepada satu. So this is how many to 1 looks like. X, the relation is the square root of punca kuasa 2 kepada X, punca kuasa 2 kepada Y. So the X, negative 2 is the square root of 4. Negative 2 also is the square root of 4. See over here you have many. Many to 1. Banyak kepada 1. And negative 1 is square root of 1. 1 also is square root of 1. So this become many to 1. Banyak kepada 1. Previously you have 1 to 1 only. Like this. 1 kepada 1. Now you have many to 1. So that already 2 types of relation. Let's see the third one. 1 to many. 1 kepada banyak. So you have like this. 1 to many. Dia banyak. 1 kepada banyak. And this one, many to many. Banyak kepada banyak. See, you see? You have lots of relation over here. Ini kepada ini kepada ini also kepada ini, and ini also kepada yang ini. So you have altogether 4 types of relation: 1 to 1, many to 1, 1 to many, and many to many. Okay, this is inverse relations. Interchanging the first and second coordinate of each coordinate pair in a relation produce the inverse relation. Okay, dia kata dekat sini, bila kita interchange, kita tukar the first and second coordinate, kita ada, previously we have coordinate x and y. Bila kita change the coordinate, kedudukan coordinate tu, kita akan produce inverse relation. Inverse relation maksudnya adalah hubungan, relation is hubungan. This is sonsang. Okay, hubungan sonsang. So inverse is sonsang, which means that hubungan sonsang or the relation is denoted as R to the power of -1. You have -1. Our original relation is this one. The inverse will be R -1. So the original relation you have x and y like this coordinate. When you have inverse relation, you see we have interchanging the first and second coordinate. Dia tukar koordinat pertama dan koordinat kedua punya kedudukan. So you will have y and x. Dia dah bertukar. Originally you have this one xy. Kalau inverse dia tukar kedudukan saja y and x. Okay. So that what does it mean by inverse relation? Hubungan sonsang. Kita terbalikkan dia. So the third example, write the relation and the inverse. Okay, now you have this relation. -2 to -8, 4 to -6, 8 to 3. So you need to write down. The relation will be it's easier for you to write it down using the order pairs. Macam ni kan dalam bentuk koordinat. Order pairs nama dia. So you write it down -2 to -8 bracket, comma, you have another one 4 to -6 and 4 to 3 and also 8 to 3. So this is the relation you have. Okay. So the inverse relation will be you just interchange the first and the second coordinate or the first and second positions. You have -2, -8. When you interchange, you terbalikkan dia, you have -8, -2. This one is -6, 4, 3 and 4 and 3 and 8. So that is inverse. Okay. So let's see. That one is relation. Kita dah belajar pasal relation ataupun hubungan. Now we're going to learn about function. Fungsi. What is actually fungsi? So, a function is a relation. See a word relation dekat situ. A function is a relation in which each element of the domain is paired with exactly one element of the range. Nampak dekat situ? Dia punya kata kunci yang dekat domain ataupun x-axis kamu dipasangkan dengan exactly one element of the range. Dia berpasang yang dekat x values cuma ada pasangan satu saja dekat y. Dekat domain ada satu, dekat range ada satu. That is function. Therefore, kita kata tadi we have 4 relations, right? 4 types of relation. Not all the 4 relation will be a function. So only these 2 is a function. Okay, so you will have 1-to-1 and also many-to-1. So only these 2 relations are considered as function because dalam function dia dah bagi tahu function tu adalah hubungan yang mana melibatkan elemen dalam domain tu dipasangkan dengan hanya satu sahaja elemen di dalam range. Dia berpasang dengan satu saja. So dekat range tu mesti satu saja. That's why you have 1-to-1 and many-to-1. The other 2 which is many-to-many and 1-to-many, we won't consider that as a function. Okay? Okay, in order for a relation to be a function, every input must have an output. Maksudnya setiap input your domain must have a pair of output or your range. And 2 different inputs can have the same outputs. 2 different inputs boleh ada satu output yang sama. Dia boleh share as long as the output only have one dekat situ. And then 1 input can have only one output. 1 input can have only one output. So that is how the relationship become the relation become a function. Let's say over here you have input or your domain or your x values to become a function over here. So you will have an output which is the range. Okay. So this is the relation versus function. So you can see it clearly how relation looks like and how a function looks like. So when you have a relation, you have this one, 4 types of relation. The first one is 1-to-1. The second one is many-to-1. This is many to 1. And the third one is 1-to-many. many. And the last one of the relation is many to many relation. So we have altogether 4 types of relations. But for function, you only consider 2 type of relation as a function, which is the one-to-one and many to one. Okay, so the output, you only have one over here, one. Okay, so I hope you can clearly differentiate what is relation, what is a function. Actually, a function is a relation, but with these 2 types of relations. Okay, this is how the function notation, how you write down your function. Y equal to fx. So y over here is your output, equal to f is name of a function. So sometimes we don't use f, sometimes we use h, k, m, any alphabet, but usually the most common we will use f as the function. And then you have bracket over here, x. This x is actually your input or your domain. Input or domain or x values is the same thing. And output, range and y values is actually the same thing. Okay. Let's see this diagram. You have input. When you key in your input, you masukkan dalam you punya input, your x values or your independent variables, you will gain a function over here. You change it into a function, then you will have a output, an output over here. Okay, bila you ada input, you masukkan ke dalam satu function, then you akan hasilkan satu output ataupun you punya range hasil dekat situ. Okay, continue from the function notation. Fx means function of x. This is how we call it or how we pronounce it. Fx is a function of x and is read f of x. Sometimes you can say it function of x or f of x. And fx equal to 2x plus 1 is written in function notation. So you have this function, this example of function. The notation f1 means to replace x value with 1. Previously we have this one, fx. Now you substitute the x with 1. So you have f1 resulting in the function value. So let's say you have a function, original function 4x plus 3. Now you want to replace the x value with 1, f1. So you will have 4 times this x, no longer x, it's become 1. 4 times 1 plus 3. So the function of 1, f of 1, will resulting the range or the output of 7. So this is how you do your function. Okay, this is about independent and dependent variables, pembalik ubah bersandar dan tidak bersandar. So the variable x is called the independent variable. Yang x values tadi will be your independent variable, and the variable y whose value depend on x is called the dependent variables. You have to at least have x values, then only you can generate your y values. For example, what you have usually in the graph like this, you have x axis and you have y axis. So this x axis or anything on the x coordinate, x values will resulting in the y values or y coordinate. So this is x value is independent variable and y is your dependent variable yang bersandar. Example 4. Okay, let's say you are given fx, a function over here. Function fx equal to 2x square negative 2x square minus 3x with the following f3. So you need to find f3. How do you find f3? f3 is you need to substitute the x value with 3. So now originally you have this one. All the x you will substitute with 3. You ganti masuk 3 tu ke dalam x. So you have 2 times 3 square minus 3 times 3. So when you key in the calculator, you get f3 equal to 9. And how about 3 times of the function fx? 3 kali function fx. So how do you do it? So 3 kali function fx is actually this one. You written it down like this. 3 times the function. This is the function, right? So you just expand it. Kembangkan dia. Kembangkan this one. 3 times 2x square. 3 times 3x. You get 9x. So at the end, you have this answer. So this is the final answer. You just multiply the whole function with 3. Kalikan, darabkan semua function ni, darabkan semua dengan 3. And how about this one? The function of 3x. So the x, the original x is no longer x. It's become 3x. Sama juga case dia macam yang ini, yang A. So you just substitute the value of this. This is the original one, fx. You substitute the x now, it become 3x. Ganti masuk x tadi ke, ganti masuk 3x ke x. So you tidak ada x sudah. All you have is just 3x. So this one 2 times 3x square minus 3 times 3x. So all you substitute with 3x. Okay. So you just expand this one, kembangkan dia. 3x square, you get 9x square. You kembangkan this one, at the end you will get function of 3x is actually equal to 18x square minus 9x. Okay. This is how you substitute the value of x into the original function. So it can be into the x or at the front of the function. Let's say example 5. Let's try a new function, which is gx equal to x squared minus 2x. See over here, we no longer call it or use f. It can be g, it can be h, k, any alphabet can be a new function. So now we have a new function with gx equal to x squared minus 2x. So find g1 plus g negative 4. Which means that this is x value. This one is also your x value. You need to substitute the x value with 1 and negative 4. So, when you substitute g1, g of 1, this x you substitute with 1. 1 square minus this one you substitute with 1. So you get negative 1. The other one is g of negative 4. Now you're going to substitute x equal to negative 4. So ganti masuk negative 4 tu ke dalam x. Ulang prosedur yang sama until you get 24. Okay, so this is how you substitute your value of x into your original function. So now you will have g1 plus g negative 4. You just plus it, sum it all together, tambahkan dia. So you have negative 1 plus 24, you get 23. So this is how a function, you create new function. From the original one, you get a new function. This is a basic shape of a function. Bentuk-bentuk asas untuk suatu fungsi. The first one is quadratic function. For quadratic function, you will have a function with fx equal to x square because quadratic. Quadratic, of course, you will have square over here, kuasa 2. So you will have this kind of graph, okay? Graph senyum, or you will have another one is graph masam, like this. Okay, so it's either like this or like this. And sorry, it is this one. This one is function of negative x squared. You have negative, so the graph will be downwards because you have negative value over there. So ni graf senyum, ni graf masam. That one is quadratic function. Let's see cubic function. Apa tu cubic function? Cubic means kuasa 3. This one. Power of 3. So you will have like S cube dekat situ kan? Ada S curve, S curve. Bentuk S lebih kurang. That one is X cube. This one is a function of negative X cube. So kalau negative, you dah boleh expect how the graph looks like. It will, you will have like this. It just contra with the previous one. Terbalik saja. And then the third one will have surd function. So surd means kuasa, punca kuasa. The graph exists only for x greater than 0. Kenapa? Dia kata graph ni cuma wujud untuk x lebih besar atau sama dengan 0. Because surd, we won't have any value for surd negative. Surd tidak boleh negatif. Dia sekurang-kurangnya kena 0. So for function surd x, you will have a graph like this. And you see for this one, you will have the negative can be outside the set, but cannot be inside the set. Okay? Maksud dia dekat sini, x must be greater than or equal to 0. X yang di dalam sini. But if you have negative outside the set, then it won't be a problem. So you just have a contra ataupun terbalik saja dia punya graph. This is upwards, this is downwards. And the fourth types of function graph is a reciprocal. Reciprocal ni macam ni yang ada 1 over dalam bentuk pecahan. Y equal to 1 over x. Dia berbentuk butterfly or rama-rama macam ni. This is 1 over x. How about y equal to negative 1 over x? So it's just a contra of this one. So you have this. Then the negative one will be like this. So this is a reciprocal. Reciprocal mean 1 over. Ada 1 per. Okay. And the fifth type of function or graph is absolute value function. Absolute value function mean you have a modulus sign dekat situ. Ada modulus. So the first one function equal to fx equal to modulus x. So modulus x mean like this. Okay. Dia ada dekat atas. Semuanya dekat atas. Sebab modulus means you will have all the answer in a positive values. And also when you have this, x square minus 3x plus 2. So this is a quadratic function. Like the first one. So you have like this. It should be somewhere dekat bawah sini kan? Sepatutnya dia ada dekat bawah sini. Sepatutnya graph tu macam ni lah. But since it is a modulus or absolute value, we will pantulkan dia. We will reflect the one with the negative side. You will reflect it upwards. So there will be no graph down here. Semuanya dipantulkan naik ke atas because you have modulus, absolute value function. Okay. Then let's see example 6. Previously you have 5 types of graph or 5 types of functions. So now let's see example 6. For each value or for each function, evaluate f0, f1.5, f negative 4. So evaluate means you need to find the value or the range, the output. This is the input. This is all the input, the x values. You need to find the y values, the range or the output. So f0 from the graph, where is f0? Meanings that you have this one, right? Coordinate x dekat 0. So your y will be here, which is 3. Okay? That's why you get 3. How about 1.5? This is x value actually. This is x. This is x. And this is x. This is your y value. Okay? So when x equal to 1.5, where is 1.5? Somewhere around here, right? 1.5. 1.5. So when you see it is somewhere around here lah, then you will get it is actually 4. Okay, and then for function x equal to -4, let's see, here is -4, you will get a y value over here which is also 4. So you have the output, which is the output, also the y value, or the range, we call range. This is all your x value or input or domain. Okay, this is a vertical line test for a function, or we call it as pencil test. Vertical maksudnya menegak, atau nama lain dia is a pencil test. If any vertical line passes through more than one point of the graph, then that equation is not a function. Dia beritahu dekat sini, kalau ada satu garis menegak, it passes through more than one point of the graph. You have this graph, kalau kita buat satu garis menegak, dia potong lebih daripada satu point, mean that that equation is not a function. Maksudnya dia bukan function. Why is it so? Because function ni dia kena, syarat dia adalah one to one ataupun many to one. Dia punya output atau dia punya range ataupun dia punya y value cuma ada 1. Exactly 1. That's why when you have line passes more than 1, that one is not a function. So let's see, we have this type of graph. When you do a vertical line test or pencil test lah ni, kita buat dia garis panjang macam ni, garis menegak. So adakah dia potong lebih daripada passes through more than one point? No, kan? They just pass one. Bila kita potong, you tengok setiap satu ni, kalau saya potong, dia cuma cut satu ni saja. Bila saya potong belah sini pula, dia cuma cut sebelah sini saja. Bila potong sebelah sini, dia cuma cut satu saja. So this, bila kita potong mana-mana pun, dia cuma cut satu saja that red line. So this considered as a function. And how about this? Bila you buat a pencil test, you cut macam ni, dia potong satu. You cut macam ni, dia potong satu. You cut lagi macam ni, somewhere around here you potong, dia cut satu point saja, kan? So this is also a function. And how about this? Bila you do a straight line or pencil test, they cut through 2 points. The first point and the second points over here. Bila you cut through over here, you will also, the line, the pencil test will pass through 2 points as well. So this is not a function. Okay, can you see it clearly? When you do a pencil test or vertical line, it should only passes through or cut only one point, then it become a function. If not, if otherwise, it is not a function. Okay, let's see example 7. Do the graph represents y as a function of x? Okay, so dekat sini dia bagi satu graph. Ada 3 graph altogether. So you need to identify whether each of these graph is actually a function. So what can we do is you perform the pencil test or vertical line test. So bila you draw a straight line, it cut through or it passes through 2 points. So this is not a function. How about the second one? When you cut through, it only cut 1 point. Dia cuma sentuh 1 point saja, melalui 1 point saja. So this one is a function. And how about this? Yes, this one is also 1. Satu saja yang dia potong. So this is a function. Okay. Next is equality of function. Equality mean kesamaan untuk suatu fungsi. Let f and g be a function. F and g be functions. So you have 2 functions, f and g. We set f and g are equal if and only if f and g have the same domain. Dua graf tadi f and g, sorry not graph, dua fungsi tadi f and g kita kata sama if and only if they have the same domain. What is domain? Domain mean your x values, your x values or your input. So dia akan sama kalau dia punya input adalah sama. So fx equal to gx for all x. This one maksudnya adalah for all x in the domain. For example, if you have f1 equals with g1 because the input is the same. The x value is the same. This is the x value. Okay, that one is equality. Let's see the increasing and decreasing function. Fungsi menaik dan fungsi menurun. Given function fx, a function fx is an increasing function. Dia fungsi yang menaik if the value of f increase as the x increases. And maksud dia fungsi itu adalah satu fungsi yang menaik kalau f tu increase dengan syarat x tu pun increase. X value tu akan increase at the same time f tu pun increase. But if you have sebaliknya, kalau dia terbalik, f decrease as x increase, satu naik, satu turun. That one is decreasing function. So this is increasing function. You have x. X you dari yang kecil kepada yang besar, then you will have a graph which is increasing. This is increasing function. But for this one, for your x is getting bigger. From this to this, x getting bigger. Unfortunately, your function is decreasing. So this is what we call as decreasing function.